One important aspect to customizing Wireshark is customizing the way in which time is displayed in the application. Now, you probably already noticed that the packet list window contains a column for time, and it's one that I recommend you always leave, and you always leave pretty prominent over to the left, because ultimately everything you're going to be doing is going to be relative to time. Either you're troubleshooting performance and you want to know the latency between certain things occurring, or you're troubleshooting or dealing with some type of security issue and you're trying to make sure the time is synchronized amongst all your log sources so that you can correlate certain types of events together. But regardless, those options or others, you're really concerned about the timing of when specific things occur in your packet capture and the order in which things occur. So time is important. You want to keep that column very prominent right to the left, and you want to do a lot of your decision making based upon time. So with that said, it should make sense that with time being of such importance, we want to be able to display that in different ways. And we talk about customizing Wireshark, the ability to customize how your time is displayed is important, and it's particularly important situationally. So depending upon the different situation you're in, you're going to want to display the time column a little bit differently. And that's really easy to do, so I'm just going to go over it quickly here, as we'll be changing that a lot with different examples throughout the book, throughout the course, and we want you to be able to quickly change that without thinking too much about it. We'll show you a couple of the different options here, and then it should become second nature to you how to change the time display format and kind of when you might want to do that. Now, in the example I have pulled up on the screen, we're looking at a TCP connection that's in progress, and we have a scenario where the receive window on the host that we're sending data to has gone to 0. So it's no longer able to receive data. We see in packet 2 right here, we have a 0 window notification. We have a couple keep alives, but ultimately nothing ends up happening. So we're not able to send any more data. Now, we'll talk a little bit more specifically about what a TCP 0 window and TCP keep alives are when we talk about finding network latency later on in the course. But for now, just know that we just have a system that's unable to send data to another system, and what we have are the packet artifacts of that. Now, if you look at the time column, you see we start with 0.00000, and that's the first packet. So we're starting from a relative position of 0, and then we're adding as we go along. So each value is more than the last, and that's going to indicate that we're incrementing. So the very last packet tells us that this entire packet capture occurred over 23.731553 seconds. So it's given us a great degree of precision there and telling us how long the packet capture is. Now, you can actually look at what time display format you're using very easily here. In this case, we're going to go to View and then Time Display Format. And this is the main area we're going to be concerned about. So here we see we're defaulting to second since beginning of capture, and we're using the automatic precision. And what we have here is two separate sections of this area. The top section tells us the format we're using, and the bottom section tells us the precision. Now, in most cases, I rarely ever adjust the precision. Whatever is automatic from the capture file is enough. Maybe if you want to decrease the clutter on your screen, you can go down to tenths or hundredths of a second. I probably wouldn't go down to any lower than any less precision than 100, I guess, in most cases, if you're going to adjust this. But for the most part, I leave it on automatic. Now, the thing of interest is going to be this section right here where we're looking at the format. Again, this is second since beginning of capture. You can also change this to interesting things like second since previous captured packet, second since previously displayed packet. So let's actually take a look at that and change that to seconds since previously captured packet. I think second since previously captured packet is really neat when you're trying to diagnose latency or slowness issues here. And I'll go ahead and notice it contracted the time column. I'm going to expand that out just a little bit here. And in this case, we're not talking second since beginning of capture, but we're still going to start at 0, and we're looking at the difference between the packets. So you see really quickly the difference between the first and second packets is very, very minuscule, nothing worth noting. Now the difference between the second packet and the third packet, it's actually 3.4 seconds, which in packet world or network communications is ancient. That's a super amount of time. It's a long amount of time. Anytime you see that type of latency between, or that type of time delta between two packets in the same conversation, chances are something is not working as it should. or maybe it is some type of keep alive, but at least in TCP communication, that means something might not be working as it should if you're concerned about speedy communication, outside the notion of heartbeats and normal keep alives that might be expected to be that slow. So we look at the next packet. It was followed pretty quickly. Again, we see 6 seconds, 6.78 seconds between the fourth and the fifth packet. Another quick packet coming after that, and then 13.5 seconds. So what we see essentially happening here is that the packets, you see these keep alive packets in this case, these are TCP keep alives, they're essentially doubling in the time they're being sent. So 3.4 doubles to about 6.78, 6.78 doubles to about 3.53, and so on. So we see that doubling in this case, which is a pretty neat thing. Anytime you see a packet, the time deltas like this between packets doubling or tripling or some repetitive interval, chances are there's some type of software configuration on the other end that's causing that. In this case, those keep alive settings are configured within Windows, so that's where that's coming from. But any type of predictable doubling that keeps occurring is certainly something that's software based and not the result of random latency or the latency from some particular type of network congestion issue. At least in that regard, network congestion can look a lot of different ways, and we'll go through that a little bit later. But in this case, this is something certainly that's caused by software. So let's change the time window again, and we'll go back here to view and time display format. And another one I really like is time of day, and you can change that to actually date and time of day, or year, day of year and time of day. You can go to quite a degree of precision, but I'm just going to change that to time of day because we're going to assume these are all from the same day, and they are because it's all part of the same conversation. Now in this case, it's going to tell us this packet capture happened about 7:55:16 with some additional degree of precision. So day and time of day is really useful when you're looking at packets that may have been captured across a large time span and you need to reference that time span, especially if you need to reference a period later in a capture to a period early in the capture. The ability to see the actual time it was taken in real time is pretty useful. Now we can go back in here and go to time display format and give it a little bit more precision. Let's do year, day, or actually let's just do date and time of day. So that's actually going to give us the date here. It's going to give us this full long format. So we see this packet capture is quite old. It was created in 2009, 3.3. I think this was created for the second edition of the Practical Packet Analysis book, given that time frame. So that's pretty cool that you can see when the packets were actually captured and make your decisions based upon that relative timing. Also particularly useful if you're combining multiple captures together. So you have 3 or 4 captures that show somewhat related activity, but it's occurring over multiple days. This will help you visually discern what parts of that packet capture are from the different days. Now, one thing to keep in mind when you're using a time display format that shows the time of day is that by default, if you chose the option I chose here, it's going to be based upon your local time zone. So it's going to have that time zone information in there in the packet capture, and it's going to store that information. So Wireshark will make that judgment based upon your time zone. So if I go under view and time display format, you'll see these first couple of options don't actually mention a time zone at all. But if you go down to the bottom, you'll see we have the same options that say UTC. So we're talking about Universal Coordinated Time or Zulu time, or essentially Greenwich Mean Time. So we're talking about that time that you generally want to use when you're trying to do any type of coordinated analysis across multiple time zones. I know in the security world, we pretty much exclusively operate off UTC because you never know what time zone people are going to be in. You never know about things like daylight savings times or what have you. So UTC is the time we're going to use in most cases. So if I'm doing just analysis by myself for a capture file and I'm not too worried about coordinating across multiple time zones, I'll use these options at the top for local time zone. However, if I'm doing anything at all where I know other people are going to be involved and they may be in different time zones, or I may be involving systems in different time zones, I pretty much exclusively use the UTC options here. So I'll continue to choose date and time of day in this case, but I'll change it to UTC, and you'll see that it changed the time in this case to 1500 hours, 55 minutes, 16 seconds, and some additional degree of precision here. So you certainly have those options available to you. One last thing here is you have the option to change things to epoch time. So we see seconds since 1970-0101, which is Unix epoch time. So if particularly if you're programming or doing something with a particular application that will only read in epoch time or is outputting logs in epoch time, you may want to compare packets you receive to that epoch time and changing that to seconds since 1971 one is going to allow you the ability to do that. And of course, you can plug that date right into a lot of different applications that are going to read that familiar Unix timestamp format. So that's going to do it for this this brief introduction to changing time display formats in Wireshark. I talked about a couple different formats. I talked about a couple different scenarios in which I would use each of those. I don't think that'll really hit home until we start going into some of the practical examples later, and you'll actually see use cases wherein we're looking at data, and by changing the time format, it's going to change our perspective on it, particularly when we're looking at things like latency, where you're going to look at seconds since the previous packet instead of seconds since the beginning of the capture. That's one of the primary use cases I can think of. But certainly we have the security perspective where we're concerned about actual time of day things are occurring, so we can correlate that to other events when we're correlating packet capture data to other log types we might have in our network. So understanding and having the ability to change time display formats is very important. I want it to eventually become kind of second nature to you, and understanding where to do that and how to use this menu and the options you have available to you are really the first step along that journey. But stay tuned. We'll continue to use time display formats of varying types throughout the rest of the course.